Hey guys, so today we're going to look at the interactive chapters in Zybooks, and we're going to go through Module 1, Sections 1, 2, and 3. That would be network topology, network types, and service providers. So we're going to go through those pieces, and hopefully I'll help you to hit the high points and kind of give you an overview of how you should be working through these. I'm not going to do them for you, but I will show you what you need to do. So let's go visit the desktop. All right, so currently we're in modules for the class. The module you need to be in is module number 1. You should have already read the overview. Basically, it just tells you what you need to do as far as this module. Essentially, it's the Introduction to Networking first module. The things you'll learn are distinguish between peer-to-peer and client and server networks, identify various networks media. You need to know the difference between bound and unbound, and also physical topologies. You need to know star from mesh from hybrid, and you need to know the logical topologies. So what you will have to do in this is watch this video, complete the various assignments and labs. There are 3 assignments plus 2 labs. Make sure going through the labs and assignments you get all the PA, CA, and LA. That's participation activities, challenge activities, and lab activities done, and then to complete the exam. Remember, you can take the exam as many times as you need to. All right, so when you're looking at the challenge activities and the participation activities, you'll find at the top of each one of the little sections here a start button. It'll be a yellow button that says start. When you click it, then you'll see this, however many slides or animation frames it has, and you can click through them one at a time, and you only receive credit once you've clicked through those. After this section, then you'll see usually some questions, just some knowledge check questions. You need to answer those, and then once you have completed all the activities for each section, you'll get a little orange check mark like this, and at that point then you can move on to the next section. When you've gotten all the check marks on a page done, then you'll have completed that page. So let's go ahead and look at the first part. Okay, topology and design. You need to be familiar with all these vocabulary words. Physical topology, you need to know bus, mesh, ring, star, and hybrid. Logical topology, you need to know that these are packet switched and not circuit switched networks, which means that the information is broken up into packets or pieces and sent out willy-nilly rather than following a fixed path like it would through a circuit, like it would through a telephone, old-fashioned telephone landline circuit. You need to know the difference between the control plane, the data plane, and the management plane. The planes are just parts of the network, and so you need to know what exactly each of those 3 does. You need to know what a single point of failure is and why it's bad. You need to understand the idea of bandwidth and redundancy. You need to be able to define those 2 words. In network medians, there are 2 different kinds, bound and unbound. Of course, bound is going to be something like copper or fiber. Unbound is going to be wireless, and you should be able to tell from that what exactly they mean. Let's go ahead and open up the lab in a new section. Okay, so network topologies, you need to read through this material. All right, this is the orange button I was talking about. When you click start, the animation will begin. And you'll click start. A network consists of 2 connected nodes. A node can be a computer, laptop, whatever. It's just a piece of equipment on the network. And then you move to the next one. A link identifies the network connecting nodes. So nodes can be connected by wired or wireless, which is bound or unbound, or both. And so here we've got a couple of laptops connected by wire. Here we've got another laptop and a router connected by wireless. Various physical topologies exist. You're going to have bus, mesh, star, ring. You need to know the basic outlines, and you also need to know why some have advantages over others. And then finally, a logical topology usually differs because the node is a multifunction device. A single physical node can logically provide multiple services. All right, you'll notice when I went all the way through, I got my little check mark up here. That means I've completed that section. So now I'll come down to the question, what term is a collection of nodes linked by at least one? That's a network. And it'll tell me correct. What term identifies the arrangement of a network? And that's the topology. Which topology type identifies a physical arrangement? That would be physical topology. and which document type identifies node configurations, and that's going to be a logical topology. All right, so once we got that done, you'll notice we have our little check mark. This is how the lessons will work. You go through the pages, go through the slides, read the material, and make sure you understand, because anything usually in bold print is going to be a vocabulary word. You need to understand why or what these mean and why they're important. So look at physical topologies. You'll go through each one. It will explain to you in the little animations, and down here also, these are the captions, why each one of these is different, and also why they're important, why some of them are more advantageous than others. So be able to need to be able to explain why some of these work better than others, and why some of them have single points of failure and some don't. Okay, then we have more questions. Same thing here. When you complete all the questions, you'll get your little orange star. Move on to the next one, logical topologies. You need to know the control, the data, and management planes and what they do. Go through the animation, answer the questions. Network mediums, only two. Bounded, which means wire, fiber, something where the data doesn't get out into the air. Or unbound, which is Wi-Fi, which means that the data is, it can travel all over. So Bluetooth or Wi-Fi, radio frequency or infrared, those are unbound. Copper, coax, fiber optics, those are bound. Answer the questions, make sure you have little stars, or pardon me, check marks in each of the little boxes. Then the challenge activities, these are a little bit more, challenging questions. So you'll hit start. Select the physical topology described in each scenario, and it'll give you the scenario. So you'll jump to level 1. A single segment case, a single cable segment with a splice for each node, and you'll pick which type that is. A central node connecting all other nodes, and you'll pick which type that is. Combination, and you'll pick which type that is. And then you'll click on check, and it'll tell you how you did it. And it'll click on next. You can't view this the instructions. You shouldn't be able to, but if you can, I'll let you use them. All right. So guys, once you're done with that, once you have completed that, then you're done with this page. Don't worry about going on to the next one down here. You're done with this assignment. At that point, then you can leave here, and you can go back to Canvas. And you have completed this assignment, and then your grade will be recorded accordingly. So then we'll go on to the next one, and it's exactly the same process. You need to know the different parts of a network. You need to know peer-to-peer versus client-server. Single location networks, you need to understand what these are and what they do. Multi-location networks, the same. Overlay networks, you need to know that these are virtual network designs. We'll click on the button down here. We'll go through the process just like we did, making sure that we get our little check marks here. So we'll look at the different notes, and it wouldn't be a bad idea to take notes on these, but let's go ahead and sit through them. Okay, nodes in a peer-to-peer model are all peers because there is nobody that is in control. Any node can act as a client or a server. It's easy to deploy because it's self-managed, but it's very, very inefficient because there's no control. Everybody has to depend on their own resources, so it gets a little complicated. Number 2, peer-to-peer model consists of a lot of nodes or only a few. It can span a great distance if it's connected by the internet. The client-server model consists of client nodes which access network resources. You get this. You don't need me to read this for you. Anyway, once you've completed it, you'll get your check mark. You'll move on, answer the questions. Single location, you need to understand what they are, what a PAN, a LAN, and a WLAN is. Multi-locations, first of all, answer the questions, get your check marks. The key to these assignments is making sure that you have a check mark in each one of these sections. If you do that, if you get these done, then you'll be in good shape, and you will get full credit for the assignment. So once you've completed that, completed the challenge assignment, then you'll go back to Canvas and you will move on to the next section. Service providers is exactly the same. I'm not going to go into it, but you'll access it down here. Make sure that you understand these concepts. When you've completed that, you'll come back to Canvas and move on to the lab. All right, the labs are just a tiny bit different. So this will be lab number 1, opening a Windows virtual machine. And essentially what you're going to do is you're going to end up with a page that looks like this. On the left-hand side will be your instructions. Also, the page navigation buttons, there will be 3 or 4 pages or 5 pages in each one. You'll click the blue arrow as you complete each page. And then as your points are received, they'll tally up here. You'll notice this is 1 of 20. You need to have 20 of 20 if you want to get credit for this lab. On the right-hand pane, this work is all done in virtual machines, so the virtual machine menu is here. This is a drop-down. You can select a Windows machine, the ZyWin01, or you can select a Linux machine, and I think it's ZYKAL for Kali. So you'll pick whichever Windows machine it tells you to connect to, and then you'll hit Connect to Virtual Machine, this blue button, and it takes it a minute to get connected. Once it does, then you will complete the instructions, moving on to each successive page until you've completed the lab. Let's go look at this one real quick. I'm not going to go into it, but I just want you to see what it looks like. All right, so here we are. This is the basic training lab. Basically, it tells you how to set up a virtual machine. This is the same diagram you saw earlier. Navigation buttons are here. Points are here. This is where they'll tally up, and you'll get a check mark here when you're done. The Kali machine and the Windows machine. You can pick the Windows machine. When you connect, it does take a minute to boot up. That's just, it is what it is. So we'll give it a minute. It's creating the virtual machine in Zybook's cloud, and it's apportioning all the resources to it and configuring it so that it runs like it's expected. But eventually it will pop, and once it does, then you'll have a Windows machine to work on. And I'll probably edit out this really long pause here. All right, so now we have a Windows machine to work on. You know, you got a start button down here, recycle bin, you have a desktop, search, you have a file explorer just like you expected. So essentially this is a Windows machine. If you want to paste from your computer into that, you use the clipboard button here. So you'll copy whatever you want to paste from your machine, click on this button and paste it into the keyboard here. If you want to open a program, you can click on the Start button, gives you the menu, or you can type in down here, let's say I want to open PowerShell. Now I can open PowerShell. So that is essentially how you will run. You'll move through the lab, and it explains exactly what you're supposed to do. You'll keep going. It tells you how to open programs and close programs, etc. Once you're done, you'll move on to the next one. Then you'll stop this one. And you'll open up the Kali machine. You'll do the same exact way. You'll come down here and select Kali, and you'll open that. You'll complete the process here. You'll go through the instructions, and then once you're finished, you'll have all your points. Make sure at the end of it you delete the VMs, just like I did, and then once you've done that, you'll have completed the first lab. The second lab, you can just go ahead and close out. The second lab is exactly the same. So you will come down here, except this one is using a virtual networking tool. So you'll go in, you'll create your virtual machine, and then you will open up a program by clicking on a project file, the Zylab topology project. And basically it's just going to open up a bunch of empty spaces. You're going to add routers and desktops and switches, and then you're going to configure them. And then once you get them configured, you're going to connect them. So you're going to add links. So you're going to add wires to establish. This program is very similar to, what's it called? To Cisco Packet Tracer. It looks very similar, and it works exactly the same way. You can build virtual networks inside of this program. So once you're done, you will have completed the assignment, and you'll click on Delete Virtual Machine. This button will say Delete, and at that point, you will have completed this assignment. All right, at that point, you will have done everything in the module but the final chapter quiz. So at that point, you'll navigate to the chapter quiz. There are 22 questions. You can take this quiz as many times as you need to, so don't be satisfied with whatever grade you get the first time. You want to retake it until you get 100. This class is designed so that you can make an A if you just put in the effort. So make sure you take this quiz, take it as many times as you need to, and at that point, you will have completed the first module. Go through the wrap-up. These are the module objectives, so make sure that you understand these things and make sure that you are comfortable with the concepts. And at that point, you should be done with the first module. You can move on to module number 2. We will probably work through labs in class, or at least partially work through them in class. I don't think I'm going to go all the way through them, but you will be given time to work on them during class. That's going to, what most of our classroom time will consist of is working on the modules in class. So be prepared for that when you come in. Make sure you have other assignments done, and be ready so that when you get done with the class each week, you can go home and take the quiz, and you'll be done for the week. So. All right, guys, I hope that was helpful. That is essentially how this class will go. We're going to work our way through the modules, and we will do the assignments and the labs, and probably do the labs in class and the assignments at our own pace and the quizzes at our own pace. And then once we're done, we will indeed and truly be done. If you have any questions, the best way to reach me is in the Canvas inbox. So just send me a message in Canvas inbox. Also, if you need help, my office is located on the second floor of the library by the back steps, room 210, or you can ask me questions in class. Have a good day, have a good semester, and I will see you around campus.